do want to ask, Zach, how you closed that gap, which seemed so hard to work around and close to those of us building voice agents, even 6 months ago, where the open-ended conversational capabilities of the models were so great. And they felt very human-like when you're talking to them. But it was extremely hard to prompt and context engineer them to get the instruction following and the function calling up to production quality. And I remember talking to you after the Llama 4 launch when we were sharing a car ride back to San Francisco and saying, like, I really thought you just had to do a ton of context engineering. And you gently pushed back and said you thought you could solve that at the model level. And I was super skeptical. But I have to say, I think you've solved a big chunk of that at the model level. Is that training data? Is it model architecture? Is it something else? What helped you close that gap?
Well, I think candidly, I think some of it's just also building on top of like the really great work that open weight models are now doing. I mean, like, forget about the speech side for just a second. I think that we saw tremendous growth in open weight models. And really, I mean, the credit goes to a lot of the Chinese labs that are really pushing the frontier of open weight models. And so I think they get like a lot of the credit, I think, for helping push a lot of this forward. And I think that and so what I think we do is we sort of take a lot of that and then we build on top of it. And I think what we have been trying to solve at Ultravox is we've long been believers in speech native models and the importance of those architectures for achieving like increasingly human-like conversations. So we've got to remove the ASR step. We've got to remove all these things. And so what we've spent a lot of our time doing is like, okay, how do you add speech as a modality without making the model dumber? That's actually, I think, an extremely hard problem because then you look at like, why does GPT real-time perform so much worse in some sense compared to the GPT-4o model? Like, well, it turns out that there's a lot of nuance, I think, in how you approach modality and there's trade-offs and stuff like that. And so I think that for us, like a lot of it was in building on top of those right foundations. And then over the last year and a half, I think solving a lot of interesting model layer and model training challenges for how we can add this speech modality without impacting the reasoning abilities of the model. I think that it's sort of, and honestly, it all kind of came together at the end of Q4. It felt like, I think that like we'd had Ultravox models all throughout 2024 or 2025, but it wasn't until the end of the year in Q4 that I felt like we really had all the pieces put together and we'd finally sort of like crack some of the nuts on the training run. And that's why I was like, oh, this would be a good test, this eval that Kwin has built. And like, let's see how we do. Because honestly, it's like, on some level, I think it's interesting because you said it was like a pretty hard eval. I look at it now, like through the lens of 2026 models. I'm like, it's not that hard of an eval, but it's amazing that it kind of is still. And so that's kind of how we sort of view and interact with the world. And I think that our big shtick too has always been that you can't just, if you want the speed, you also can't just train the model. You have to run the inference layer. We haven't figured out how to outsource inference to someone else whose primary job is not real-time inference, but also is tech stuff and not seeing massive sort of like very widespread on latency numbers. And I suspect if we were to sort of break down and graph out a lot of those requests on the text layer, what we would see are very wide distributions and like time to first token numbers, for example, just because of you don't know where you sit in the queue and stuff like that. So I think for us, it's a combination of the modeling work and then figuring out some of the serving techniques as well that hopefully allowed us to kind of close both the latency gaps, but then also the intelligence gaps.